Now, in balancing of redox reactions, there are two mediums in which redox reaction can be balanced. The first one is the first one is acidic medium, while the second one is basic medium. What I'm trying to say here is that there are two ways in which the redox reaction can be balanced. The first one is acidic medium, the second one is basic medium. But let's look at the what are the principles that involve in acidic medium. The basic principle of balancing ionic equation in acidic medium. The first principle is to write down the half equation to show the species that reduce or the species that oxidize. Now, let's look at the equations. This equation, and then you want to let's write out the the equation in ionic form. In this case, we have MnO4 minus plus Fe2 plus give out Mn2 plus Fe plus 3. Now, therefore, K and sulfur has nothing to do with the equation. Why? Because they are spectator. Because they are spectator in the sense that the ionic form, the charge on the ion does not change. Their charge remains constant. Therefore, they are referred to as spectator species. In this case, we have MnO4 minus reduced to Mn2 plus, ion 2 to ion 3. Therefore, from this equation, now you know which species that is oxidized, the one that is reduced. Now, the first thing you need to, the second one is balance all atoms except oxygen on the left and the right. Okay, we are through. Let's look at the ion. The manganese is one here. Manganese is one. Fe is one. Fe is one here. Okay, and then that one is balanced except oxygen. Now let's now look at this. The second one. The second one is balance all the atom except. Okay. Now we don't have issue with the second one. Let's now go to the third principle. The third principle. The third principle stated that balance with respect to the charge by adding appropriate number of electrons. In this case, we are going to divide the equation into two aspects in terms of reduction and oxidations. Here, let's use this side for reduction. We have manganese reduced to manganese 2 plus. Here, iron 2 plus oxidize to iron 3 plus. Now, when you calculate the manganese here, we have X plus open bracket minus 2 times 4 equal to minus 1. That means X minus 7 and minus 8 equal to minus 1. That means your X minus 8 equal to minus 1. X is equal to minus 1 plus 8, which is equal to 7. Then we have 7 this side, and this side is 2. And then you can rewrite it as MnO4 minus plus 7 give Mn2 plus. And then the charge difference now is 5. Then we are going to add 5 electrons to this side where you have excess in order to reduce. Then we have MnO4 minus plus 5 electrons give Mn2 plus. Why this side we have plus 2 here, and then here is plus 3. Then we are going to add just electron here to balance. That's the third principle. And then let's now move to the fourth principle now. The fourth principle. The fourth one said determine the difference in number of oxygen atom present in the left. Now we have, if you go back to the fourth one, you know that you have four oxygen, and then at the right side, no oxygen. That is in the reduction side. Now for this, let's look at how you can balance it up in terms of oxygen. That we have MnO4 minus plus 5 electrons give Mn2 plus, and then we have 5. This side is Fe2 plus give Fe3 plus. Now let's now determine that the difference of oxygen is 4. Let's now move to the next principle. Say replace the difference in oxygen atom as being present in water. Since it's 4, let's rewrite it again. Then we have manganese O4 minus, and then plus 5 electrons gives 2 plus, and then plus we are going to represent with 4 molecules of water. These 4 molecules of water indicate to represent the oxygen. Now let's write this side again. Plus 2 give ion 3 plus electrons. Okay. Now after representing, and then this side again, you now count how many hydrogen ion do you have here. 4 times 2 is 8. Then we are going to use 8 hydrogen ion to this side. That will be MnO4 minus plus 5 electron plus 8 hydrogen ion give Mn2 plus plus 4 molecule of water. Now write this one just to keep going, not to be confused. Plus, then let's now move to the next principle. The next principle, balance the half equation so that the number of electrons lost equal to the number of electron gain. Okay. Now let's look at the in the reduction side. We have manganese minus plus 5 electron plus hydrogen 8 hydrogen ion give manganese 2 plus plus 4 molecule of water. There is reduction side. And then let's now look at the oxygen side. We have ion 2 plus to ion 3 plus plus 1 electrons. This oxygen side. And then from here, let's look at, we have 5 electron, we have single electron here. That we multiply this reduction side, sorry, oxygen side by 5 to balance. Therefore, we have 5 ion 2 plus to 5 ion 3 plus plus 5 electrons, and then from here is balanced. That means the electrons, cancel the electrons. That's if cancel the electron. And then let's now move to the last principle. What will be the last principle? Now they say add the half equation. That means you're going to add them together. You're going to add this equation to this. You add them together. Now let's start from the reactants. The first one is MnO4 minus plus 8 hydrogen ions plus 5 plus gives M2 plus plus 5 ions 3 plus plus 4 molecule of water. But you need to write in such a way that we have MnO4 minus plus 5 iron 2 ion plus hydrogen ions give 2 plus 5 ion 3 plus 4 molecule of water. Now that equation is balanced. Now let's now rewrite it perfectly here. That is our equation. That means the general equation for the ionic equation for that reaction now is we have MnO4 minus plus 5 ion plus 8 hydrogen ions give manganese 2 plus 5 ion 3 plus 4 molecule of water balance.